pressure of air, whatever other gases you might have. Actually, the septic tanks, the tanks that come to take your septic tank stuff away, what they do, they have a vacuum on the top of their tank that sucks the air out of the tank, correct? And then try to take the liquid. So what happens there? There is less vacuum inside. You don't need the tank walls to shrink down, correct? That is part of your decision when you make that. So this rho zero could be considered as the pressure, real pressure from any gases. Usually in civil engineering, we look at it only the pressure from the atmosphere, which if you go here at the sea is going to be known all over the globe. Go to Mount Hood at 8,000, 12,000 feet is going to be less. Go to the Dead Sea in Palestine is going to be double than Mount Hood, correct? Because you are at 1,000 feet below the sea level. So that is some differences. G, we know G, H, we know H, and this is density of the liquid. Okay? So this is something, sometimes we put you to calculate some kind of pressure, and all you need is just to draw it in your brain. Do I have any gas pressure here to add? Or I'm at Portland, I don't consider the atmosphere pressure. And then I deal with P. When I deal here, so we call it the gauge pressure, just on whatever comes from the liquid in that basin, in that system, in that tank, in that swimming pool, it doesn't matter. And the only thing, whenever we deal with liquid, the liquid at any wall goes from the top of the liquid, 0, and goes in triangle on each wall. And in order to find it, we need to get this simple formula by finding the volume in that area of the liquid times the density, correct, times the G. Agree? So the volume times the density give you the mass, times the G give you the weight. And you know this distance here, is 1/3 of the H. And this A here, the volume is the area included underneath that. That's all. So when you deal with any liquid, you use this formula and you deal with it exactly what we did in here. The only thing is you need to calculate this triangle to place A and where to place it. That's all. Is this clear? Okay. The pressure of the liquid is not going to be included in the test. Actually, no, they don't teach it here at the college, or they didn't mention anything about it. I don't understand why. When
that program, fluid mechanics.
yeah, you will do, yeah.
We have this in physics.
Yeah, it's in physics.
But again, this is not all the time is about the fluid mechanics. Also, questions on this? Questions on this?
Is this pretty much all there is, chapter 5?
Done with chapter 5.
You're done?
So chapter 5 is about to start fighting the centroid. Why we need to find the centroid? In order to place a pin force, a concentrated force, arrow, in replacing a distributed force. Or when we deal with areas, we need sometimes to find the center of gravity in order to apply the force. That's all. Now, you can, some of you misunderstand this. Some of you will be working finding center of gravity for all three of this. Instead of having 12, 12, and 3, find one center of gravity. of all of them of 27. That is not wrong. It's time consuming. So you can find center of gravity for these three on X. So you can find Xi for each one and measure it. This is Y direction and measure it, and you will find Xi's times Xi AI and the areas here, AI, for each element. Add them together, divide them by area, and you will get one force, which is going to be the 27. Okay?
A lot of time.
We don't say it is wrong. You can find the center of gravity for all the areas included, and you will have one force, time one distance, correct? And create the moment. And in this case, you will say the moment here is going to be what, 27 times D equal the moment 120, or D equal 120 over 27, 42. Yeah. So, if you go here and find the center of gravity for this, is going to be from here to here, 4.4 meters. And the total force is going to be this. You can do that. Not wrong. But try to make it your life easy by dealing with areas that you can divide it. So here, I divide it into 1, 2, 3, or 1, 2, 3. It doesn't matter. Each one, I know its own center of gravity, I deal with it. Why I need one center of gravity for all three of them? There is no need. Make sense? Questions on chapter 5? Okay, in the test, you will be asked from chapter 415. Usually, you have questions like this one, like this one, like the one with forces. That is one question possible. A question of finding center of gravity for a certain shape, and again, nothing wrong with that shape. It's nothing weird, something that we solved here, or something in your book that you solved. And we go back to chapter 4. What was chapter 4 about? Chapter 4, what? Equilibrium. There will be another 2 questions there. So I usually, when I start, I sit home and I put these 4 questions. I'm not going to give you 4. I just put myself 4. Question like this, question like finding the centroid. That's from chapter 5. Then I go to chapter 4 and I find finding the rigid bodies, equilibrium, whatever reaction, whatever, and I will put it from there another. Then I eliminate them to 3 questions according to I don't know. The 3 questions, and again, you will be asked. Sometimes I keep it 4 and ask you to force you to select A's, B's, or one from this question, one from this question, to cover both chapters. Make sense? Yeah. Okay, practice, solve problems. We are not going to take the test this Monday, but the following one. Okay, have a good evening. If you don't have questions, you are free to walk.